Video is going to be discussing solving inequalities, both one variable inequalities and compound inequalities in one variable. So, what the big thing here to remember is, as far as solving is concerned, we solve just like we would an equation. All the rules that we would follow while we're solving an equation, we follow while we're solving inequalities. The only difference comes in if you multiply or divide by -1. If we do that, we do have an extra rule that we have to follow. But let's look at an example. So 3x minus 5 is greater than or equal to 2 parentheses x plus 7. Okay, so we go about solving this, and this has variables on both sides, so like we would do if this were an equation, we're first going to simplify down both sides. So our left-hand side becomes 3x minus 5 greater than or equal to. Our right-hand side is 2x plus 14. Okay, now here we have to move all the variables to one side of the inequality. And we would do that just like we have with our equations. We're going to move the 2x in this case. So when we move the 2x, we end up with x minus 5 is greater than or equal to 14. And then to finish solving, we add 5 to both sides of our inequality, and we get x is greater than or equal to 19. Okay, this is one way of expressing our solution. The other way that we have used has been to work with graphs. And the big thing about our graphs is that we want to keep them simple. So I have a closed circle over my 19 because this is an equal to inequality. And because it's greater than, I go to the right. Now, as we stated, if we multiply or divide by a negative, really, it doesn't just have to be -1, but hear me out here for a second. When we multiply or divide both sides by a negative number, not needed, what we are actually doing is this. Or at least how we would finish solving, we have to do something like this. So let's say we have -4x not equals, -4x is, let's say, strictly greater than 12. Okay. Here we have to divide by a negative. So when we divide by our negative, what happens is twofold. First off, we have the opposite sign of what we started off with on both sides of the equation. So on the left-hand side, we started with a negative, now we have a positive. That is the opposite. On the right-hand side, we had a positive, now we have a negative. So because we have opposites here, we have to take the opposite of this sign, which is just less than. So this graph would look something like this. Again, just keeping it very simplistic. We don't have to have a super detailed graph. Because this is just a less than inequality, there is no equal to. We have an open circle, and because it is less than, we go to the left. Okay. Compound inequalities work similarly. The difference in compound inequalities is that they come in two varieties. They are either, if we're looking at the picture of them, a split or a trapped inequality. This is if we're just looking at the pictures, because a split inequality is going to look something like this. Whereas a trapped inequality is going to look something along this lines. So are we trapped between two numbers, or are we able to go away from the center? So this is if we're looking at the picture, but if we're looking at an equation, a split inequality is an OR inequality. So we would have something like 4x minus 5 is less than 6, or 5x is greater than 20. So what do we have here? Well, two problems, really. Two separate things that we need to solve. So let's solve this one first. The variable is all the variables are on one side of our inequality. So we're going to add 5 to both sides as we are undoing the subtraction. And that's going to give us 4x is less than 11. And then we would divide both sides by 4, and we end up with x is less than 11/4. On this equation, we just need to undo the multiplication, and we do that by dividing both sides by 5. So we divide both sides by 5, and we end up with x is greater than 4. So our solution for this is x is less than 11/4, or x is greater than 4. Now, our trapped inequalities are similar, except they're and inequalities. So that would be something along the lines of 3x is less than or equal to 12, and uh, and negative 5x is less than negative 20. Nope, less than positive 20. Let's do positive 20. So we have this set up here. Now, over here we would solve this half of our problem, just like we would any single inequality. We divide both sides by 3 to undo the multiplication. X is less than or equal to 4. And over here, we divide both sides by negative 5. Because we are dividing by a negative, we end up taking the opposite sign, and is going to be greater than. So let's look at what this is saying. This is saying that I am a number that is smaller than 4, but larger than -4. So I have to meet both criteria. Over here, I can be one or the other. Over here, I have to be both, which is how we get the trapped nature. Okay, that will do it mainly for this video. Only one more thing that I want to mention. For the exam, it is going to be vital that you can look at inequality graphs and determine the inequality. So going from graphs to inequality. And it's also going to be important that you understand that reverse relation. So being able to look at a graph and come up with an inequality, or look at an inequality and solve it and come up with a graph. That will do it for this video, and I will see you